Continuing with naming, and I'd just like to reiterate that if you can't get naming, the rest of things get really difficult, because if you have to write the name or the formula based on the name before you can do the balancing, before you can do the stoichiometry, it sort of throws you for a loop if you can't get through the name. So here's a couple of rules, and they're listed out. We're going to follow along. Unless it is a group 1, 2 element, or aluminum, zinc, or silver, we must give the oxidation number in Roman numerals. So when you see iron 1, 2, 3 something, that is telling you that iron has a charge of +3. The cation, the metal, the positive, whatever it helps you to remember, goes first, and the anion, or the nonmetal, or the negative, goes last, always. You would never see hydroxide iron. It's always going to be iron hydroxide. If the nonmetal is not a polyatomic ion, we change the ending of the chemical name to something "ide", like oxygen becomes oxide. Hydrogen becomes hydride. For the ionic compound formula, we're always going to do the same thing. We're going to put the cation first. We're going to put the anion last. So whether we're naming it or writing the formula, we always do the same thing. The metal, the positive first, the nonmetal, the negative last. Then you're going to write the symbols and determine the oxidation number for each. So let's say I want to do the bond between aluminum and chlorine. So I would write aluminum is a +3 and chlorine is a -1. Then we're going to cross our numbers and bring them down. So this would be Al1, and we don't write the 1, we can leave that blank. Cl3, aluminum chloride. And so we're going to cross those oxidation numbers down as subscripts. If this was a 2 and a 6, we would take it down to a 1 and a 3. Remember, we eliminate, we reduce down to the lowest number. So if we want to look, I know, like I said, I know you guys have a hard time seeing. Hopefully you're following along your own sheet. CaO. Ca is calcium, O is oxygen, so calcium. Calcium is a group 2. It doesn't need a number. And oxygen becomes oxide. TCF4, TC is tactinium. Tactinium is definitely, he's not one of our group 1s, he's not one of our group 2s, he's actually a group 7B, but that means that he's a transition metal. So we don't know what he is unless we check to see the other subscript. So this means that we have I can't spell technetium. There we go. And so fluorine is a -1, and so you can see that the tactinium doesn't have a subscript, so that's okay. We know that it had to be a -1 and for the fluorine. But the fluorine has a subscript of 4, so that means this guy had to be a +4. So we should write 4 in there, and then fluorine becomes fluoride. Rb3PO4. Rb is rubidium. It is a group 1. Group 1s don't need the Roman numbers. So we can just write rubidium. And PO4, that is our phosphate. And since it is a polyatomic ion, we don't have to change it to an ide. We would just leave it rubidium phosphate. And then we come over and look at this, Zn for zinc, Cn2, that would be cyanide. And zinc is another one of our special exceptions. It doesn't need a number, just like silver or aluminum. So zinc, cyanide. So looking at the next 4 examples, now we're going to go from names to formula. Silver chlorate. Chlorate. That makes me know that it's a polyatomic ion. So silver is Ag, and Ag would have a +1. Chlorate is ClO3, which is a -1. So if we cross those, we get, please don't leave them with the oxidation numbers up like that. They would cross down, and since these guys would both be 1, so we would get AgClO3. Lithium hydroxide. Lithium is Li, and it is a +1. Hydroxide is OH, and it is a -1. So if we cross those, once again, we get LiOH. Next one, vanadium 5 sulfate. So vanadium is telling me that it has a oxidation number, in this case a +5. Sulfate, SO4, that's a -2. Let me just write this over here. So when we cross their oxidation numbers down, we get V gets the 2 from the sulfate, and the sulfate, now I need brackets because the whole thing gets a 5. Iron 2 phosphide. Not phosphate, phosphide. That means it's a phosphorus. And iron 2 means it is Fe plus 2P. How do you know what the phosphide is? Well, you got to go to your periodic table. Phosphor is, where is it? It is a group 15 or a 5A. So it would normally have, would like to gain 3 electrons. So it would like to add a charge of -3. So now we can cross these guys, Fe3P2. A Lewis dot structure showing magnesium chloride. Well, the magnesium, he's way over here. Way over here. He could either gain 6 or lose 2. Well, losing 2 sounds like a lot easier. So the magnesium had 2, and now it's going to go to having none. It's going to have a charge of +2. The chlorine had 7, and it's much easier for it to gain 1. But how many chlorines do I need to take these 2? I need 2 chlorines. So my magnesium becomes Mg plus 2 with nothing, and my chlorines are all full, both of them. So they'd have a charge of -1. This whole thing. All right. So let's go ahead and finish these last little ionics, and then we'll stop here. Hydrous compounds have waters attached. So an anhydrous compound lost its water. So if you see K2S dot 2H2O, that is potassium. And potassium is a group 1. It doesn't need a number. Potassium sulfide. And now there's 2 H2Os, so we're going to say dihydrate. Add the hydrate. So what is the formula for iron 3? Fluoride pentahydrate. Iron 3. So that'll cross down. Fluorine is -1. So the -1 goes over here. We're going to have 1 iron and 3 fluorines times penta, 5 waters. FeF3 times 5H2O.